You can all sit down and start listening to our first speaker. Please welcome Anna. Anna Ahuir Baraja is a biologist, and she works at the Oceanographic through an agreement between University of Valencia and La Ciudad Valencia de las Artes since 2003. She's very passionate with all the parasites from all the fish of the Oceanographic, and her PhD is on parasites of mola mola, the sunfish. Her presentation today will be on fish parasites, 120 fish parasite species.
Okay. Thanks for this introduction. Good morning, everyone. Well, this is the title of my talk: Oceanographic, fish, mammals, birds, and 120 fish parasite species. At the Oceanographic, we can see 3,000 different species of fishes from all the oceans and seas. But these fishes don't arrive alone at the aquarium. They come with a high number of special guests, the parasites. All fishes in natural conditions have parasites. So it is very important to study these parasites. Why? Because it is a good opportunity to increase our knowledge about the parasite biology and diversity, and of course, to keep healthy fishes in our exhibits in two ways: with an exhaustive parasitological control and testing treatments. Because if you know who this parasite is with a correct identification, and you know the modes of transmission among the fishes, you can apply the correct treatment to decrease the damages caused by the parasites. So what is the parasitological research at the Oceanographic? Well, since 2003, the University of Valencia, with the support of the City of the Arts and Science and University of Valencia agreement, has been developing this task with aquarium fishes. This is possible with the resource of the research lab at the Oceanographic and the laboratory of the Marine Zoology Unit of the University of Valencia, in which we have the microscopical elements to identify the parasites and the specific bibliography related to the parasites. For developing this task, we have a routine protocol in which the daily losses go to the veterinarian lab, where they are weighed, measured, and we take photographs if the fish has bones or ulcers on its surface. Then the fishes are analyzed parasitologically. At the necropsy, we analyze the skin, the hair, the muscle, digestive system, and gills. But we pay special attention to the skin and gills because it is there where we can find the parasites that can cause problems in our exhibits, the parasites with direct life cycle, as the protozoans, monogenians, copepods, irudinians, and isopods. All of them cause problems of infection, reinfection. We can see in this example of a life cycle of a monogenian that the adult specimen, which lives in the skin or the gill of the fishes, releases a high number of eggs, from where the infected larvae, called Onchomyriacidia, hatch and swims to find again the fish for infecting it. Furthermore, the injuries caused by the fixation organs of these parasites favor the appearance of secondary infections caused by opportunistic pathogens as bacteria and viruses that increase the damages caused by the parasites. We can see in this illustration of a copepod infection in gills that the parasite increases the mucus secretion and makes injuries. So the exchange area is decreasing, and the opportunistic pathogens magnify the infection, and they can produce an immune system hyperreaction that can make the fish die. Well, now we know what the parasites can do, and now we can see what are the most common parasites that we can find in our exhibits. First of all, the protozoans, with our friends cryptocarion irritants, most commonly named marine itch. We can find it in the skin and in the gill of the fishes. And in the gills, they produce this typical swelling in the gill epithelium. We can see in the videos the trophon stage of the parasite. This is the stage in which the parasite can feed the mucus of the fish. And this is a parasite is very hard to eradicate for the exhibits. And today it's caused a lot of problems in aquarium systems and aquaculture systems. Then the monogeneans, as Benedenia and Neobenedenia, we can find them in the skin and in the gill of the fishes, and most of them feed the host blood, so they can cause problems with anemia. Then Irudinians, most commonly named leeches, we can find them only in the skin of the fishes. Most of them can act as vectors of bacterial and viral disease, and of course they feed the host blood and they cause problems with anemia too. Then copepods, the sea lows, we can find them in the skin and in the gills of the fishes. We can observe the different morphology of this group of parasites, and in the adult specimens we can see these structures, the EUACs. And the last group, isopods, Asnatia and Ceratotoa species. We can find them in the skin and in the mouth of the fishes, and they can be very hard to eradicate, and they can cause problems of anemia too. So, related to the results and scientific divulgation, 2,500 fishes have been analyzed, from which we calculate more than 10,000 parasites from 120 different species. And these results include 12 Congress presentations with talk and posters, new host records, species redescription, and best of all, new species of parasites. Let me show you the new species of parasitic copepoda, Caligus hydrolagi, found in the skin of some specimens of spotted ratfish, Hydrolagus colliei. We can see the illustrations of the female and the male of this new species of parasite, and this paper is published in the journal Folia Parasitologica. But there are more papers in preparation, as the review of the parasite fauna of the spotted ratfish, remarking these two new host records for these two species of Irudinians, found for the first time in Hydrolagus colliei, and the redescription of the Trematode Cotylogaster michaelis, found in the digestive system of some specimens of striped sea bream from the Mediterranean Sea. So to conclude, in an aquarium there is a high diversity of fish, but a high diversity of parasites too. We can work in controlled conditions of temperature, salinity. There are a low number of problematic parasites, and we can work in the best place to design treatments and preventive procedures, so the fishes can be relaxed because they are well cared for. Thank you for your attention.
We have time for questions. Is there any? We can't see very well. Okay. No questions? Okay then. Thank you very much, Anna. Very nice paper.